Hello and welcome back to the LNG Industry Podcast. I'm your host, Jessica Casey, editor of LNG Industry, and for this episode I'm pleased to be joined by Daniel Mann, Chief Commercial Officer at Bound for Blue. In this episode, we're going to be talking about a new technology that's picking up speed as an alternative method of powering ships, specifically LNG carriers, wind-assisted ship propulsion, or WAPS. I hope you enjoyed the episode.
LNG Industry serves as the go-to hub for all those following the latest developments in the LNG sector, providing spotlight interviews, in-depth articles, and regional reports. LNG Industry covers the global marketplace. Register to receive a print or digital copy at lngindustry.com.
Hello Daniel, welcome to the podcast and thank you for joining me today.
Thank you.
So before we get into the topic of today's episode, please can you introduce yourself to our listeners and tell us a little about your role at Bound for Blue?
Yeah, my name is Daniel Mann. I'm the Chief Commercial Officer at Bound for Blue. I joined back in 2024 and I lead the commercial activity with a team of sales personnel that support customers to educate on our solution and how our solution can help their business and their vessel fleet.
Perfect. And as an introduction to the focus of today's discussion, could you provide a rough outline of the technology behind wind-assisted propulsion and how it works?
Yeah, sure. So wind-assist propulsion systems take advantage of the available wind to generate clean forward thrust, so reducing the engine power that is needed for a vessel, which subsequently cuts fuel consumption and emissions of the fuel that is otherwise saved. So modern WAPS, wind propulsion, is really the same as traditional sails and aircraft. So we combine the basic aerodynamic forces of lift and drag. However, compared to the traditional sails that you would see in old ships, modern WAPS are capable of generating significantly more force due to the shape optimization and the advanced aerodynamics. So a little bit like the old sails on vessels, they're using that wind to propel the vessel and reduce the fuel on a ship.
Okay, and are there many different varieties of wind-assisted propulsion available? How do they compare in terms of performance, installation costs, and suitability for vessels such as LNG carriers?
Yeah, so different WAPS technologies include suction sails, which is what our technology is, rotor sails, and rigid sails. So suction sails like Bound for Blue's e-sail is a suction sail that combines the best attributes of rigid sails and rotor sails. So as an example, the Bound for Blue e-sail generates 7 times more lift than a conventional rigid sail. Also, e-sails have minimal power consumption and low mechanical complexity to ensure simple, safe, reliable operations. All of these key features to support optimized installation on an LNG carrier. So the different types of technology come in different sizes. So that's one of the main differences, which makes some of the technologies easier to install than others. In addition to the weight, there's different weights of the different sails as well. In addition to that, the performance will vary. Even larger sails doesn't necessarily mean you'll get more savings than a smaller sail, because like our sail is more powerful per square meter, we can have a smaller sail and generate more performance than some of the smaller sails. It's a good question around different maintenance costs as well, the different complexity of maintenance and what's needed. Our e-sail is low maintenance because its design is designed to be non-really intrusive in terms of maintenance and crew intervention. It's autonomous, so it's controlled by a control system that adjusts to the wind, and some minor maintenance that's needed each year and a 5-year dry dock. But a low level of components with low complexity, meaning that the crew can operate the sails in confidence without having to intervene to a great level.
As I'm sure you're aware, there obviously appears to have been a recent uptick in the adoption of WAPS, especially in the LNG carrier sector. Why do you think this might be?
Yeah, so we are seeing strong growth in WAPS as ship owners, charterers seek to reduce their operating costs and help manage regulatory compliance as well. The compliance out there, different regulations, is tightening the cost of carbon and the fossil fuels that are used. So if you can reduce that carbon by reducing your fuel, that is one of the best ways to manage regulatory compliance. But also technologies such as WAPs can help operators seek a competitive advantage in an increasingly complex industry, because as markets are tight, charterers such as oil and gas majors, LNG traders, will want the most efficient ships to reduce the cost of the fuel that is used to transport the cargo, but also to support regulatory compliance and sustainability out there in the market.
And are there any technical and operational challenges for integrating WAPs into existing LNG carrier designs?
So, it's a little bit case by case, because you've got a variation of different types of LNG carriers out there, from the first steam propelled vessels that were built up to the modern two-stroke design today, and in the middle period, four-stroke DFDE. So you've also got different hull designs, different shapes of the ships. So it's important to conduct a detailed feasibility study for WAPs, vessel integration, to ensure there is no adverse impact to vessel operations on a case-by-case basis. You will have sister ships, you will have some vessels in a sort of bucket that are closer to each other, but then you'll get some variation from the first ships that are built to the ships that are built today. In terms of some of the challenges or things to consider, maintaining existing air draft is important to ensure access to ports and terminals. So the height of the sail that's installed must comply with the current air draft if possible. And also the vessel's hazardous zone plan needs to be reviewed to check WAP's compatibility requirements with a hazardous zone. And we recently signed a partnership with UK-based consultants Cryosafe Services, and this partnership will support the installation studies, reviewing all the aspects, including air draft, hazardous zone, but also cargo operations, gangway, air draft, etc., and making sure that all owners and charterers are confident the vessel going into terminals with WAPs will comply with the terminal requirements and constraints.
And sticking with installation for a minute, is there an impact on the installation of WAPs on the cargo capacity, depth arrangement, and overall hydrodynamic performance of LNG carriers?
So there is some impact, WAPs, on those elements for each vessel. Again, depending upon the specific design, propulsion of the ship, and the way the operations is factored in for that vessel and the trade routes. So again, all of those elements need to be assessed on a case-by-case basis. The impact on those elements of WAPs will really depend upon the size of the sail that's selected, the weight, the quantity, the number of those sails that you choose to place, and the placement of the sail on the vessel and its location. And like I said, the specific LNG size and type of vessel. Up to now, all of the studies we've made, minimal impact on those elements that you mentioned, and we certainly have solutions to manage any impact on those elements.
What training and skill requirements might be needed for LNG carrier crews to safely operate and maintain WAPs?
Yeah, so Bound for Blue, we have offered crew training and conducted crew training. As an example, with Maersk Tankers, a lot of the crew, to give them more details on the solution and how to consider the operation of the sails during their operation of the vessel. And that each sail also has its own control system, which controls the sails and adjusts automatically to the wind conditions. So the operation of the sail is automated. That said, it can be put in manual mode, and that can be done during port operations, but also for some training. And we do a level of training during the commissioning of the sails when the vessel is launched. As a good example, Odfjell actually, with the modern vessels today, a lot of automation, a lot of the crew today are not actually experienced in the traditional sailing with sails. So they sent them on a dinghy route out there in the sea to get some experience with sailing with old-fashioned wind propulsion. So it is useful to brief the crew on the specifics of the technology, which is different today than it used to be.
With longer trading routes, how might weather routing and voyage optimization influence the performance and efficiency of WAPs on LNG carriers? Are routes better suited than others?
It's certainly an emerging and growing trend to combine wind propulsion with weather routing. A lot of vessels and operators are using voyage optimization routing today, but putting wind into that is a little bit different because you've got to make sure the technology provider of the the voyage weather routing software has the specific knowledge of the specific sail technology that's being put on the ship, because each sail has a different impact towards different wind directions and wind speeds. So you need to adjust it specifically. And certainly in general, all WAPs benefits from weather routing because you're looking to find the most optimal wind conditions for that technology. And at Bound for Blue, as an example, we work with a number of weather routing companies such as Napa, part of Class NK, and other makers to provide them with our eSail performance polars. And that is really the range of wind conditions that's best suited for our solution. They use that information and program their software and prepare their software specifically. And when they work with an owner, they're setting the routes and optimized routes. They will consider a lot of different things in terms of just-in-time arrival or the ETA of the vessel, where it can operate, where it can't. And then within those sort of parameters, find the optimum wind conditions to get the maximum savings.
And you touched on this briefly a little bit earlier in our discussion, but what role could WAPs play in helping LNG carriers comply with future international maritime decarbonisation regulations? Is it currently recognised by any of the regulatory bodies?
Another good question and an emerging trend in shipping. So WAPs can certainly play a major part supporting regulations, decarb regulations. It's likely we'll see even more of a commercial tiering of LNG carrier markets based upon efficiency. So WAPs can help differentiate the LNGC segments for competitive advantage. And this will be more pronounced with the tightening of regulations such as Fuel EU, which tightens again in 2030 in terms of the cost of carbon of the fuel that is used. Of course, you have different phases of markets where there's more tight market, which is less ships available. A lot of deliveries happening now, so there'll be more. And when there certainly is more ships in the market, then charterers will want the most efficient ships with the most reduced fuel and the best decarbonized solution on that vessel. Fuel EU offers a wind reward based on the installed wind power. So depending upon the actual installed power of wind, you get a bonus, which is against the GHG greenhouse gas intensity calculation. So there's a bonus that can be achieved by having wind on the vessel. There's also the benefit of the EU ETS through a reduced fuel consumption with wind propulsion on the vessel. And I know a net zero framework, which is still in discussion and debate being worked on at the moment, will be further discussed during NAPC 85 in November. And the proposal there is that wind propulsion will be part of the GFI greenhouse gas fuel intensity target. So there'll be a benefit from using wind on the vessel.
Okay, and then looking to the future a little bit, how could advancements in lightweight materials, automation and artificial intelligence enhance the performance of WAPs for LNG carriers?
Yeah, so like most technical providers of the different equipments, we're constantly investigating different options for either how we can reduce the cost and the complexity of a product, how we can improve its performance and other factors. So as an example, in terms of the material, we're using a steel structure, which is suitable for compact T-sails because we are smaller. We can use a heavier material. A lot of our competitors using composite, lighter weight, but they're bigger structures, which means the weight is still quite pretty substantial compared to our e-sails. And saying that, we are using some different components like the top and bottom plates, aluminium, and also investigating, are there some components where, some carbon fiber will help optimize the overall weight footprint. And there's a lot of options out there today in terms of the material. You mentioned AI, and of course, data is a key enabler to operating sails and enhancement of performance. When we set up the control of our e-sail, that's based on certain parameters of how our sail works with the wind conditions. But then another thing is when the sails are put into operation on a specific vessel, which is a little bit different case by case, vessel to vessel, and of course, route to route. So what's important is the data we get back, high frequency data we get back on the operation of our sails with the operation of the vessel. And that information allows us to fine tune the control of our sails to increase savings even further. And with AI that can help us in the future to do that quickly, more intelligently, that will add to the performance even more.
Okay, great. I think we covered a lot there. So thank you again, Daniel, for joining me today to discuss the emergence of WAPS and explaining in more detail what makes it so well suited to the LNG carrier segment.
Thank you. Pleasure to participate. Thanks a lot.
I hope you enjoyed listening to this episode of the LNG Industry Podcast. The podcast is available on all platforms, so listen for free and please rate, review and subscribe to ensure that you never miss an episode. Until next time.
LNG Industry serves as the go-to hub for all those following the latest developments in the LNG sector, providing spotlight interviews, in-depth articles, and regional reports. LNG Industry covers the global marketplace. Register to receive a print or digital copy at lngindustry.com.